Welcome to another physics class. During our last lesson, we look at Newton's first law of motion. And I promise at the end of the lesson by then that today we are going to momentum. So momentum is simply defined as the product of mass and the velocity of an object. I take it again. Momentum is simply defined as the product of mass and the velocity of an object. Right? Momentum is simply defined as the product of mass and the velocity of an object. The product of mass and the velocity of an object. It means from what is on the board, momentum is mass in motion. Momentum is mass in motion. Then mathematically, we can now say momentum, the symbol is P, is equal to mass multiplied by velocity. That is, momentum is equal to mass multiplied by velocity. That's the formula of momentum, where P is momentum, M is mass, and V is velocity. So from there now, we can now say the unit of momentum. Don't forget, from one of our lessons, we discussed lengthily how to derive unit of each quantity in physics. So from here now, the unit of momentum will be, for mass is kilogram, for velocity is meter per second. So it means the unit of momentum is kilogram meter per second. And the momentum is one of quantity that have basic unit directly as its own unit, that is kilogram, meter, and second. Momentum is a vector quantity. Momentum is a vector quantity. And don't forget, when you say vector quantity that have both magnitude and follow a specific direction. Now, the next thing is examples of momentum. As I said, let's look at examples of momentum. The first one is a heavy truck versus a bicycle. A heavy truck versus a bicycle. A truck has more momentum than a bicycle because it is much heavier even if they move at the same speed. That is, if both the vehicle, that is the heavy truck, and the bicycle move at the same speed, the heavy truck will have greater momentum than a bicycle because of its mass. Number two, a baseball hitting a bat. When a baseball hitting a bat, the bat transfer momentum to the ball, causing it to fly away. That is, when a baseball hitting a bat, the bat transfer momentum to the ball. It causes it to fly away. So if you look at the bat as shown on the screen and the ball, as according to the explanation, so the ball fly away when the bat transfer momentum to it. Three examples of momentum. A car crash. That is, the impact of a car crash is determined by the momentum of the cars involved. The heavier cars typically having more momentum than the lighter car, as you can see on the screen. The heavier car having greater momentum than the lighter car. Example, a bowling ball versus a soft ball. A bowling ball has more momentum than a soft ball because the bowling ball is heavier in making and it's harder to stop. Therefore, it has more momentum than a soft ball. Number 5 example, a short bullet. That is, a moving bullet has a large momentum due to its high velocity, even though its mass is very small. But the fact that it moves with high velocity, it has a large momentum. See, as shown on the screen. This example, a super tanker in sport, a super tanker in port. That is, a super tanker will require a slow approach to the port because of its enormous mass, momentum. That is, for a super tanker in sport, it will require a slow approach to the to the port because of its great mass and its great momentum. A runner, as shown on the screen, a runner with greater mass and velocity will have a greater momentum. 8 example, as shown on the screen, bouncing in squash. That is, a squash player hitting a ball on the wall and then hitting it again, increasing the velocity and momentum is also a typical example of momentum in action. 9 example, as shown on the screen, pole vaulting. That is, the use of a soft landing pad in pole vaulting help to reduce the impact force by increasing the time over which the momentum change occurs. The last example, which is number 10, as shown on the screen, is the exhaust gases from a rocket. The exhaust gases have momentum, and this momentum is transferred to the rocket, which propel it forward. And various examples of momentum that we can have. We can have more than this, but this is just to mention but few. Any question, if you have to state or mention examples of momentum, so you can add from the list on the screen, or you can still add your own point according to which will be related to what we have seen now. The next thing we are going to look at is change in momentum. Now, according to the definition we gave the other time, the momentum is the product of mass and the velocity. As the object is moving, although the mass is constant, but the velocity as a vector quantity will keep on changing. Due to the changing in velocity now, definitely there will be change in momentum. Therefore, we must have, when you have change in momentum, delta P, change in momentum. That is, this one means that since we have velocity changing, we can have that we delta P will be equal to the initial momentum, the final momentum minus the initial momentum. And since momentum is mass times velocity, so if the final momentum is mv, that is, m will be mass of the object, v will be the final velocity, then it will be equal to minus the same m into u, where u is what? The initial velocity, and mu will be the initial momentum. So our delta P, as I said, which is change in momentum, will give us mv minus mu. M is the same, so we are going to have m into bracket v minus u. So the change in momentum will give us this formula, where this delta P, as I wrote on the board, is change in momentum. M is the mass of the object. M equal to mass of the object. Then V is final velocity. U is initial velocity, where this our mv is final momentum, then mu is initial momentum. So that is what we mean by change in momentum, saying there will be change in velocity, although the mass of the body remain constant. This point now, from change in momentum, this one will now lead us to Newton's second law of motion. And the Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force. I take it again. Newton's second law of motion states that the rate of change of momentum, as explained on the board, is directly proportional to the applied force. Let's write, that is, Newton's second law of motion states that the rate, don't forget, when you say rate in physics, time is there. The rate of change of momentum is directly proportional to the applied force. The rate of change of momentum is directly proportional to the applied force. That is, mathematically, we can now say that F is directly proportional to delta P. Don't forget, we say our delta P is change in momentum. But according to the statement, the rate then over T. Because, as I said the other time, when you say rate, time is inclusive. That is, the rate of change of momentum is directly proportional to the applied force. So from there now, don't forget our change in momentum. Then this one will now give for K is a constant, delta P over T. So substitute the change in momentum from this formula with delta P. So we are going to have F is equal to K is equal to M into V minus U, then over T. Now, K, as I said, is a constant. K is equal to constant, which can be equal to 1. If K is equal to constant and is equal to 1, then we are going to have F, that is force, is equal to M into V minus U to bracket over T. Now, don't forget from linear motion, we've already explained that A is equal to V minus U over T. That is, the acceleration is equal to V minus U over T. So if V minus U over T is A, then we can now say that F is equal to ma. Here F is equal to force applied and m is equal to mass of the object, and A is the linear acceleration. The next thing we are going to look at is examples of Newton's second law of motion. We want to look at various examples of Newton's second law of motion. Don't forget, under the first law, we look at examples also. We want to look at example under the second law now. Now, as shown on the screen, the first example is an airplane take off. When an airplane take off, it's a typical example of Newton's second law of motion. The number 2 example as shown on the screen is skateboarding. Skateboarding also is another example of second Newton law of motion, followed by lifting weight. When you lift a weight, is another example of second Newton law of motion. Another one is rowing a boat. Rowing a boat is another example of second Newton law of motion. Another one we have on the screen is braking a vehicle. When you apply a brake to a vehicle, is another example of Newton law of motion. The next we have on the screen is a tennis serving. When you serve a tennis to another person, is another example of second Newton law of motion. Look at the screen again. Look at the next example. Watering plant with a hose is another example of Newton's second law of motion. Then we have here again pushing a lawnmower. When lawnmower is being used to cut grass, then the person pushing it applying Newton's second law of motion. Move to the further example as shown on the screen. We are pushing a grocery cart. Pushing a grocery cart is another example, followed by launching a rocket to the sky is another example. Another one, using a hammer to hit any hard material is an example of Newton's second law of motion. Then, when you are using blender at home to blend anything, is making use of Newton's second law of motion. The next example is stepping on a gas pedal. Stepping on a gas pedal is another example of Newton's second law of motion, followed by swinging on a swing. That is, swinging a side swing is another example of Newton's second law of motion. The next is using a bicycle. Is another example of Newton's second law of motion. Then jumping up is another example of Newton's second law of motion. Now another set of examples, driving a car is another example of Newton's second law of motion. The opening and closing of door is another example of Newton's law of motion. Then pushing a child on a swing. When you put a child in a side swing, as I said the other time, is another example of Newton's second law of motion. Throwing a ball is another example of Newton's second law of motion, followed by vacuuming a rug. When a rug has taken dust, then you need to vacuum it. Is a typical example of Newton's second law of motion. Playing soccer is a typical example of Newton's second law of motion. Then squeezing a ketchup bottle. Squeezing a ketchup bottle is another example of Newton's second law of motion. Then rowing a boat, as I said the other time, and many other examples. To mention but few. If the question asks you, state or mention examples of Newton's second law of motion, you can mention from the list on the screen, and you can still add your own, which is relate to the example under Newton's second law of motion. Let's stop here for today. When we meet in the next class, we want to continue with all this formula that is force acceleration of a body under Newton's second law of motion. We are going to continue with that in our next class. And as I always say, if you are just joining us today or you are with us before, please try to like, share, and subscribe. So when I upload a new video like this, you will to get the notification in time. Thank you.